All right, today we're working with what's called a compound inequality, and we really already have the tools in our toolbox to do this, but we just have to see the adjustments that are made if it is what's called a compound inequality. So we're going to be asked to solve and graph the solution. And you'll notice right away, you will see why it's called a compound inequality. Do you see why it is called compound? There's two inequality symbols, right? That's why it's called compound. It does not make it any harder, it just means there's a little bit of extra work to do, and we have to pay attention a little bit more. I'm still going to solve this for x. If I was going to solve this for x, let's say that I was just thinking about this side over here. Wouldn't I add 3 to both sides? Right? Well, if I was going to solve this part over here for x, I would do the same thing. So we can actually solve the whole thing simultaneously, all right, by adding 3 in all 3 spots. Okay, and watch what happens. When I do that, negative 2 plus 3 is 1, is less than or equal to, those go away, x, which is less than 7. All right, and we have solved the compound inequality. Doesn't it kind of look like a sandwich? All right, the x is sandwiched in between two numbers. And when I graph this on the number line, we have to follow what the sandwich is telling us. The x is sandwiched in between 1 and 7, okay? So it's less than 7, but greater than or equal to 1. So the solution set on the number line is sandwiched between those two numbers. All right? And so it's really not complicated. It's just you have to understand that the x in my solution is stuck between two things. Okay? And your graph and your number line will show that clearly. All right? Let's do another one. Six is less than or equal to r plus 7, and r plus 7 is less than 10. This is also a compound inequality. It's just presented in a little bit different way. All right, so what we do is we just solve each piece, and then we put the whole graph together. This word "and" is very important. It means that both conditions have to be true. So on this first inequality, if I subtract 7 from both, then I have that negative 1 is less than or equal to r, or I could think r is greater than or equal to negative 1. Over here I subtract 7, and this says r is less than 3. And because of this word "and," it acts just like this first problem that we did. So let's look at what the solution would look like on the number line, and that'll really clear it up. Here's 0, here's negative 1, 1, 2, and 3. My solution says that r needs to be bigger or equal to -1. So there's -1, and I know it needs to be bigger than that. But it also, and it needs to be less than 3. Open circle, less than 3. So guess what? This is just another sandwich problem. Because of this word and, my solution says that the r's have to be greater than or equal to -1 and less than 3. So it turns out to be another sandwich type problem, even though it's kind of presented a little differently. Okay? How about this one? You'll notice on this one that it has the word or. Well, or is not the same word as and. This means one or the other needs to be true. So let's solve both of these. A is less than 3, or add 1, add 1. A is greater than or equal to 4. Now, let's think of what this looks like on the number line. Here's 3. Here's 4. Here's some other numbers around it. Now, let's look at what this says. It says A is less than 3. Well, that's open circle, less than 3. But because of this word or, we can consider something going the other direction. Greater than, this says A is greater than or equal to 4. So I color in the circle, and I shade that way. So my shading is going in opposite directions, but that's totally okay because of this word or. It's just saying one or the other needs to be true. It either needs to be less than 3 or greater than or equal to 4. And that's how we can shade in opposite directions. One last problem. Negative 2m plus 7 is less than or equal to 13. Or 5m plus 12 is greater than 37. Once again, we have the word or. So we're going to solve them both separately. Let's see how that works out, and then we'll go from there. Subtract 7, subtract 7. Negative 2m is less than or equal to 6. Divide both sides by negative 2. M is less than or equal. Oops, I divided by a negative. My mistake. I divided by a negative, so I need to make that a greater than or equal to negative 3. Easy mistake to make. And then I solve the other one. Subtract 12. Subtract 12. 5m is greater than 25. Divide both sides by 5. M is greater than 5. But we have this word or. So let's look at the graph here. The number line sketch. Here's 0, negative 1, 2, negative 3, 1, 2, 3, 4, and 5. Now, my answer says that m needs to be greater than negative 3 or greater than 5. Well, here's negative 3. Color in the circle. Shade to the right. Well, here's 5. I don't need to put an open circle because if I shade all of it, I'm meeting the OR condition. If you pick any number, for example, on this number line where I have shaded, it's going to satisfy this OR. If I pick the number 1, 1 is greater than negative 3. But because of the OR statement, it does not have to be greater than 5. All right? I could pick a number here that's 7. Here's 7. 7 satisfies this one. M is greater than 5. So my answer is the way that I graphed it. Now what I want to show you is how would this answer have changed if instead of OR, I had AND. If that would have been the word AND, then they both must be true. Which means I only could shade to the right of the 5. Because anything to the right of 5, anything over to the right of 5 is both greater than 5 and greater than or equal to negative 3. So you have to pay attention to this word in the middle. If it would have been AND, my graph would look like the greenish yellow shading. And we will stop there for today.